Welcome back. Adam Soroka here for Future Downstream. I hope you've enjoyed it today. I certainly have. I've taken a lot of key takeaways today. Really interesting discussions and also nice presentations from some of the guys who've been presenting today. I've really enjoyed that sort of balance specifically as well. We have one coming up now from Fabrizio D'Antonio, Asset Integrity Manager, Raffineria di Milazzo. Fabrizio's presented with us before, really knows his stuff on asset integrity. So his presentations on monitoring and management of corrosion to distillation units of a petrochemical refinery. So over to you, Fabrizio.
Hello, my name is Fabrizio D'Antonio. I'm operative maintenance responsible at Raffineria di Milazzo, and I'm going to present the work concerning the monitoring and management of naphthenic acid corrosion in distillation units of a petroleum refinery. Okay, the aim of our study is to maximize the use of low-cost crude oils that are obviously characterized by higher acidity and higher sulfur content compared to the sweet oils. These oils give us the possibility to increase the margin, so to get more money from our process. But this is also balanced because of the higher integrity cost, because this high acidity and high sulfur content oils obviously put in danger the plant because of the higher corrosion mechanisms that they have. So we can see the damage mechanisms and the mitigation modes in these sections. They are caused by higher acid content, naphthenic acid content, or higher sulfur content. In our work, we have used the corrosion inhibitors that form a protective layer on the metal surface. You can see from the pictures in this slide, you can see how the corrosion attacks the metal in our piping, and the corrosion inhibitors form a protective film on the surface of the metals, and this film prevents the corrosion mechanisms. We have at Raffineria di Milazzo, we have two crude distillation units. Number 3 crude distillation unit is intended for low sulfur crude processing, and number 4 is for high sulfur distillation. We did the project first with the risk matrix definition. So we assessed the corrosion rates, and a low corrosion rate is less than 0.13 millimeters per year. Medium is between 0.13 and 1 inch, 0.254, and high corrosion is greater than 0.254. Also, there was the selection of the corrosion inhibitor, and also the choice of monitoring and definition of the points that are more in danger, let's say. So we used a dilution carrier for the corrosion inhibitor to guarantee a good distribution, and placed the injection point very close to the column to a better distribution also inside the vessel, inside the column. And the nozzle have been oriented co-currently to the stream. The choice of the corrosion inhibitor was to go to a thiophosphate ester family, and there is the stabilization of an iron oxide film that prevents the corrosion to attack the metal. As for the monitoring, we use the ultrasonic probes that are adapted to be used in high temperature elements, because obviously the temperature is the most important factor that increases the corrosion mechanism. The higher the temperature, the higher is the corrosion mechanism. Normally, testing ultrasonic testing, so we cannot measure the thickness if the piping is in service, because the temperature is too high. With these probes it is possible, and so this gave us the possibility to monitor the corrosion. So we can see on the next slide how were the corrosion probe placed, and it's up to temperature. They can be welded or magnetic connection. And there are some pictures of how the corrosion measurements were placed, probes were placed. The acquisition from the probes is with the Permasense. These probes are Permasense wireless sensors. We did the network via antennas that are put on every probes. They talk to each other and go eventually to a gateway which is above the control room. So the gateway acquires the signals from each of the components of the probes, because they talk to each other, as I said before. And from the control room, there is a virtual machine on a host server, and the program, which is called the Plant Web, is installed on this virtual machine. And then there is the data transmission from the gateway to the control room via optical fiber.
Yep.
Now we go to the how on the plant it has been developed the system. The arrows are the injection point, and the red dots are the thickness measurement points. So we put the injection point upstream the preheating train and the heater, obviously, and the measurement points obviously has to be put on the higher temperature point, because as I said before, the higher the temperature, the higher is the corrosion rates. Very important is also the metal which is the metal of the section, because, for instance, stainless steel has a greater resistance to corrosion compared to low-grade carbon steel, and so, but obviously the cost is higher, and so we have to protect some section even the temperature is lower, because of the metal which is cheaper in the section in which obviously it has been designed to be so. So we have these measurement points which are upstream the heater and at the outlet of the heater. As for the column, we can see this on the transfer line is one of the injection point, and also in the intermediate and the HGO reflux, and where it has been checked the thickness, which is on each of the streams to the column and from the column. In the lower section, because the bottom section is obviously the highest temperature section. This is just to show how something has been arranged and how is the injection point and which sensor, how many sensors have been put for each stream. let's go to what we have seen as for the results. We have to say we did a reference period was 6 months, but I have to say that the sour oil crude was processed for some weeks, just some weeks, but this has been just a reference to us to be sure that the system is reliable and we can use it, and we say so that it is possible to do that. So the data from the sensor were plotted versus as a time function versus time, and was carried out a linear regression. And so we had the equation of how the corrosion rate is going. This is the trend because we obviously have this corrosion rate probes are online and sent to the DCS, so we can trend the thickness. We can see that the measurement are always very close. So there was not a big problem concerning corrosion, even because we used, as I said before, inhibitors. So comparing the results, we have okay, in this column you can see average corrosion rate in millimeters per year was low, very low, compared to both the Meconomy prediction, which was the prediction from the researcher who studied the corrosion, and also to our risk-based inspection corrosion rate, which are our prediction from our risk. So both for CDU4 and CDU3, we had good results as for corrosion rates. As I said before, we did an extrapolation and plotted the line, and so we could get a corrosion rate which is good for the CDU4 is 0.054 millimeters per year. For the 3 is the same, let's say. So the conclusion. I have to say that, so the corrosion rates are comparable with the average monthly values. No increase in corrosion. I repeat, just because we also use the inhibitors. So we have been negligible thickness losses, or nearly so, means that not higher than what we expected. And obviously the corrosion inhibitor made it possible to control the corrosion attacks. Obviously, I have to say that Meconomy curves are very conservative, but they are also studied without corrosion inhibitors and normally takes the worst case scenarios. And as I mentioned before, the period in which the acidic crude was treated was quite short. But we had a very good insight of how to work and what to do in the future. If we want to, for sure we would use some very heavy crude. Thanks for your attention.
Thank you, Fabrizio. That was a fantastic presentation on crude distillation, which I know a few of the people that have logged in wanted to have some summarizing notes on that. That's a very high level topic for downstream in particular. So thank you, Fabrizio, for sharing your insight